Hi, I'm Annie Masick. I'm a junior, and right now we're in the CAD lab, and I'm going to introduce you guys to Mr. Winterbore.
My name is Mr. Winterbore, and right now we are in CAD 1. CAD stands for Computer Aided Design, and so in this class we introduce students on how to use computer software to create three-dimensional models. So like back here right now they're working on creating a digital model of a house that then they can move throughout kind of in a virtual kind of scenario. We also use this for smaller objects too. So one of the projects we did earlier was a little puzzle cube where they modeled in software this puzzle cube, and then we use a 3D printer to print it out in here in real life so that then they can take home with them their own design and creation that they've made. We've also do things like we made cookie cutters where they design their own cookie cutter and we can 3D print that after they're completed. So it's really just meant to be kind of a fun introductory class into this computer-aided design concept and process. But it has real-world applications. Whether I tell some students, some of them might just want to use this as a hobby, but professionals use it too. Engineers, architects, designers, all the skills that you learn in this CAD class can help you in those fields if you want to pursue more expertise in that.
Hi, I'm Sophie Steffes. I'm a senior. Right now I'm in CAD 1, and I'm actually have been working on creating magnets with a 3D printer. First, I designed it on our computer software, and right now you can see that I'm printing one. This one's going to be KU, and I also have some finished products. This is what they look like, and yeah, I just designed these on some software, and then I set it up on the computer, and the computer sent it to the 3D printer, and then you get to pick your color up here, and yeah. I'm planning to major in architecture, so I'm really excited to be in this class, and I think it's really going to help me in the future.
Hi again, it's Cali D'Augusto, and now we're down in the Honors Chemistry Lab with Ms. Tunick.
Welcome to Honors Chemistry. This is a college prep level class in that the students that leave this class will be ready to take chemistry in college and will be at the top of their classes with that chemistry in college. We do a lot of hands-on activities. We like to be in the lab. Just last week we were playing with fire. This week we are working with spectroscopes, and we also do a lot of online learning and tying together with our group that's on the computers right now, which we hope will be going away soon. We have a pretty strict curriculum here, and it's pretty rigorous. They work really hard, but they learn a lot, and I think they have fun. Do we have fun?
Yeah.
And that's the Honors Chem program.
I'm Natalie. I'm a sophomore, and I love honors chemistry because we do a lot of really fun labs. And I think it prepares me really well for college because I'm thinking about going to the medical field in the future.
Hello, I'm Gozi Okafor. I'm a sophomore, and I take honors chem because it really prepares me for my future in the medical field, and it's a very good challenge for school.
Hey, Shantise again, and we're in the STEM lab with Mr. Berth in his physics class.
This is the STEM lab, and at Marion, the girls take biology as freshmen, chemistry as sophomores, and physics as juniors, and all of the girls do that. And then senior year, they can choose a different science course to take. And then this is where we're having physics right now. And right now, the girls are doing a lab where they're trying to use one of the constant acceleration equations. And what they can do, they're dropping an object, and they're timing how long it takes to hit the ground. And with just the timing and the fact that they're falling at an acceleration of 9.8 meters per second squared, they're going to calculate the distance that it fell, and then they'll actually measure that distance to see if they were close.
Okay, so what we're doing is we're dropping a ball from the same height that we dropped other objects, and we're trying to get the same speed and the same distance to get them in the bucket.
We'll put it into the table that we have for the lab, and then we've defined the average time for each object we dropped, and then the average distance for each object.
And then we have questions that asks us which one had the closest distance, which one had the furthest distance, and we have to explain why and everything.